Here we go. I think we can see your slides, but we're in, there we go. There we go. We had slide infinity for a second.
Oh, okay. So all good, right? You can see the slide and you can hear me.
Yeah, all good to go.
Okay. Welcome to HashiTalks by me. My name is Shazin. I'm a senior engineer working for Arteria. And today I'm going to talk about GitHub authentication managed by Vault. So before I delve into it, I would like to give a brief overview of what Arteria is and who we are. So we are into a digital contracting space, which means that we are trying to help the world contract faster, which includes drafting, negotiations, approvals, and even data extraction from existing contracts. We officially started late last year, and we have had a steady growth since then. We got a Series A funding a couple of months back. We also have had a steady growth with respect to our headcount. We are 30 plus right now. So to know more about Arteria, you can visit arteria.ai or visit our LinkedIn page. So let's jump onto the topic for the day. Git. Git is one of the most popular version control system. Like everyone else, we at Arteria use Git for our version control. We use GitHub Enterprise Cloud for our source code management. So last year, when we got a GitHub Enterprise Cloud license, the first question that came to our mind is, how are we going to authenticate users against GitHub, especially from a command line? So GitHub provides a couple of options for authentication, but they all came with a couple of challenges. One of the options is the HTTPS option, where you enter your username and password to authenticate. But we all know that username and password can be easily compromised. And it was against our guiding principle across the organization that we should always provide short-lived credentials. So one workaround that GitHub provides is to use PATs, personal access tokens, but asking users to create short-lived PATs every now and then is an inconvenience for them. So we thought about, we wanted another option. So the other option GitHub provides is the SSH way of authentication, where you create a key pair, a public and a private key, and you upload the public key to GitHub, then you authenticate. It is seamless. The problem again is that the credentials are not short-lived. So as long as your public key is on GitHub and you have your key pair with you, you'll be able to authenticate to GitHub. So it becomes pretty difficult if there is an attack across the organization. The access revocation becomes a bit difficult. You'll have to ask each individual user to go to GitHub and revoke the public key. That's not something we wanted to do. So what's the alternative? GitHub then started supporting SSH certificate-based authentication, I believe around 2019. So how does this work? You have to define your certificate authority, a CA, a custom CA, and add it to GitHub. Then you can sign the public keys of the users with this custom CA, along with details like your GitHub username. So this produces an SSH certificate, which you can use to authenticate to GitHub. That was pretty good because we were able to define the validity of the certificates. You can set it as 1 day, 2 days, or 3 days. Similarly, if there is an attack in the organization, there is a single point of revocation. All you have to do is go to GitHub, recreate the CA. So all the certificates that were signed by the previous CA becomes invalid. So that's pretty good. But like everything else, it came with a challenge. And that was, how do we sign the certificate, or who will sign the certificate for us? So going the manual way was definitely not an option. Plenty of risks. The primary one being that there is a risk of exposing the CA private key if I'm going to do it from my machine. And it's an unnecessary hassle for developers or users in general that you have to ask a human being to get your access certificate. And end of the day, we shouldn't be doing it because we are supposed to automate things. Machines should be doing it for us rather than us doing it. So we had to look for an alternative, an engine that can do for us. And we found Vault. Vault fitted all our requirements. It provides us a signed SSH certificate engine, which is pretty simple to set up. All you have to do is enable the secret engine, configure your CA, and once you have the roles in place, start signing. Pretty simple. But it came with a few challenges. The challenge was that we didn't want to expose Vault UI or Vault CLI to the end users. The reason being, we didn't want users to log into a system to get their passwords every day. We consider that as an inconvenience. And moreover, we didn't want to expose the underlying infrastructure because things could change underneath. So it's always good to have a layer of abstraction on top of it. So what do we do? So if you ask me, what we wanted at that point was, we had a couple of end goals that aligned to our principles across systems in Arteria. So when it came to GitHub, we wanted a setup where we can access GitHub without any credentials at all, if possible. If not, with minimal credentials. We wanted to avoid a secret sprawl where we had many different passwords for many different systems. The other being that we wanted onboarding and offboarding to be automatic. If that is not possible, at least with minimal manual intervention. So how do we do it? And we wanted to make sure that the system is secure when we do this. So we got thinking, we wanted to do this with Vault and implement the GitHub SSH certificate-based authentication. We got thinking and thinking and thinking. And then we came with this. I'll give you a few seconds to run through this. I am going to explain it piece by piece. So on the rightmost side, the black triangle, it's all familiar for us, it's Vault. So that is the integral piece of this whole structure. And I'm going to go clockwise. Then we have the application DB at the bottom. Then there's GitHub, where our code is stored. Here is Azure AD, where our user lists are stored. And then we have SharePoint, which is the file storage that we use. You can use any file storage for that. So let's see how an end user interacts with the system. Say Emma joins Arteria. She completes her onboarding process. She's all excited and she wants to get started, which means she needs access to GitHub. So what is she going to do? She's going to create a key pair, a public and a private key. And she's going to upload this public key to a private SharePoint directory that was automatically created by a process. It's a private directory, only she has access to it. Okay, so now her public key is in that private SharePoint directory. Every night, a job runs that is going to pull this public key from there, get it signed by Vault, which means there is an SSH certificate now, and pushes that SSH certificate back into the SharePoint directory. Emma also does one thing. She syncs the SharePoint directory to her local, which means that every morning when she logs in, she has the latest signed SSH certificate on her machine, which means she doesn't have to have any kind of credentials in her system to access GitHub. All this happens automatically. So how does this work in the background? Let's start with Vault. We use AWS and we use AWS EKS for all our deployments. So we were able to use KMS auto unseal with Vault. So what does this translate to? So for those who have used Vault, you must be already familiar that Vault has an unsealing mechanism where you need 5 different tokens. It's using Shami's secret sharing algorithm. We didn't want to store 5 different secrets. We were just 2 in the infrastructure team. So there we got to know about KMS auto unseal. We used that, so there are no credentials required to get Vault started. We did something similar for the app too, that is in the middle. It's a Spring Boot app. We used the Kubernetes auth mechanism, which again means that we don't need to store any kind of credentials in there. For the authentication with Vault. So what does Vault do? So as you see here, the app talks to multiple systems. For all these integrations, it needs credentials. And all these credentials are stored in the Vault KV secret engine, which is, for those who haven't used, is a very simple and secure way of storing your secrets. And then we are running the SSH certificate signing engine by Vault. So how is the signing process done? So we using a Spring Boot app as the orchestrator. We call it the Secret Manager app. We use the Spring Vault project for integration between Spring and Vault. Like I said earlier, we use the Kubernetes auth mechanism, which makes it very easy for us for the authentication between the app and bot to work. So this app does 3 things every night. The first job, it syncs user list between Azure AD and the app database. What does this mean? So assume it's the first run. The database is empty. It is going to pull all the GitHub users from Azure AD and it will populate in the database. In the subsequent runs, it is going to make sure that if a new user has been added to Azure AD, it gets added to the database. So once this job is complete, we have the full user list in the database. The second job syncs data between GitHub and the database. What are we doing here? Or why are we doing this? Because to sign an SSH certificate for GitHub, we need to have GitHub username in place. So we are going to fetch all the users of our organization from GitHub and make sure that those username gets updated in this database. So after the first 2 jobs, we have the full user list in the database, plus their corresponding GitHub usernames. Now we are all good for the signing process. The next job does the signing process. It pulls the public key from SharePoint for each user, fetches the relevant data from the database, goes to Vault, gets a signed SSH certificate, pushes it back to SharePoint. So this runs every night, which makes sure that every night the latest SSH certificate is there for every user in Arteria. And they all sync their SharePoint to their local machine, which means that every employee or every GitHub user in Arteria, when he logs in the morning, he or she logs in the morning, there is his or her latest SSH certificate for GitHub access. No credentials required. So how does this look in action? So I wouldn't be able to show you the nightly job definitely, but we do run an admin UI where we can run this certificate generation logic ad hoc, because there are certain scenarios where we require it, like a new employee joining. So she or he doesn't have to wait till end of the day for the certificate to be generated. So this is a screen recording I did this morning. So I fiddled with the certificate a bit to have an older certificate on my local. So first I'm going to show you the validity of the current certificate. If you see, it was generated on November 16th, 5:59 p.m. And it is valid for the next 3 days. We generate 3 days valid certificates. So it's valid till tomorrow, 5:59 p.m. So now I'm going to go to the admin UI and generate a fresh certificate, which means that it will create a certificate, push to SharePoint, and I'll have it locally immediately. So let's go to the admin UI. It's a simple single page app that we built. I'm going to enter my Arteria email address and click generate. So this does all those things I was talking about. So once it succeeds, it means that the certificate has been pushed to SharePoint, which means it has been synced to the local. So now if I go and check my certificate validity, you can see that it was signed this morning at 10:46 and it's valid for the next 3 days. So this is how it happens. Normally, we don't have to run this admin UI stuff because it happens automatically. So let's come to the benefits. From my experience so far, the primary benefit has been that the users do not have to swear any kind of credentials for GitHub. To be honest, even the infrastructure team doesn't have to keep any kind of credentials for this whole mechanism to be running. And yes, the onboarding, offboarding process is minimal. We were able to achieve both of our goals. As you have seen, it's just the initial setup. From then on, it just goes on automatically. And all the certificates have short-term expiry. We create certificates which are valid for 3 days. And yes, if there is an attack, the revocation is pretty simple. You go to GitHub, recreate the CA that invalidates all the existing certificates. So folks, this is how we use GitHub in Arteria. It's pretty seamless, no credentials required, no going to secret manager server and getting your passwords. Thanks to Vault and thanks to HashiCorp for helping us to realize this. Here are the references for all that I've talked about. GitHub SSH certificate authentication. This is a blog by GitHub on how this works. Then we have the Vault components, the KV secrets engine, the SSH signing engine, how to do auto unseal with KMS, how to implement the Kubernetes auth method. Then there is the Spring Vault project, which is a pretty good project. It provides a very good integration between Spring Boot and Vault clusters. Then there is Microsoft Graph API, which we used for our communication from the app to Azure AD and SharePoint. Then there is GitHub GraphQL API, which we used for the communication between the app and GitHub. So that is it. If you have any questions, comments, you can put it on the YouTube chat. I know it's the last presentation for the day. I am going to leave you with this. Over to you. Thank you.
I had to pause to read the comic. I love it.
Thank you so much, Shazin. Thank you for walking through that pretty interesting use case, integrating like workstations to just have proper security. I dig it. And thank you for wrapping HashiTalks Canada for us.
Thank you.
If there are any questions, take them to the YouTube chat for Shazin or any of our speakers. It seems a number of them are still hanging out there.